Welcome back, my darling students. So we're actually going to walk through a written out example. I pulled it straight out of the book, but I did this because they did a really good job of writing what each of the steps are, but we're still going to talk through it and then we're still going to work some. It's just nice. Some people really like to see each step with what you're doing written out. So I figured just copying the picture over was the best way to get that. It would help if the image was in order though. There. I think the Word doc you guys have is fine. This is probably just a copy paste issue. There we go. So the big catch for synthetic division is you have to be dividing by something that looks like this. It doesn't have to be a minus, it could be x plus a number, but it has to be just an x. So 1x, not 2x, not half of an x, just x. So we're dividing by x minus c. So the number that goes in the little box here is not the number you see, but the opposite. What I like to do is I take my part on the bottom, what I'm dividing by, the divisor, set it equal to 0 and solve it over. So x equals 4. So 4 is the number that went in that original box. Now, what we're doing here, the behind the scenes, is we're kind of asking ourselves, is x minus c a factor of this larger polynomial? Does x minus c divide nicely into that? We're going to get some other interesting results out of this, but that's the initial first big step, big idea here. All right, so then I just write the coefficients down, but I must make sure they are in order and that I have any necessary zeros. So I look up here at the original problem. See, a 2x cubed is the biggest. So I start with the 2, then I have the x squared, so minus 10. There's no x terms, so we put a 0, and then the minus 5. So they're in order like that. Now we're going to kind of do this down, up, down, up, down, up, kind of over and over. So we have the c value, we have our coefficients, and it is very common to put that little backwards L around the c number just to keep it distinct. But those all usually go on the same line on lined paper. Skip a line, put the big bar. Then the very first step is you draw the 2. You bring down that first coefficient. And if you notice in all of our long divisions, especially when it was a linear factor, when it was just an x, the number part was just the number we started with. Then we multiplied. Now remember before, we did the multiplication and then we subtracted. By moving the c term to the other side, we have actually subtracted it over. We've changed the sign of it with my change it and circle it. So by having the opposite number here, I'm also taking care of my subtraction in one step. So we just multiply what's in the C box times what I just wrote down here, and then we write it up here. So 4 times 2 is 8. And because my subtraction was taken care of with the 4, I'm going to add now. So negative 10 plus 2 is negative 2. And then we do it again. The 4 times the negative 2 would be a negative 8 going in here. And then we add and get negative 8. 4 times negative 8 is going to be a negative 32 that we see down here on this last line. And we add and get negative 37. And then yes, very often they'll put a normal looking L to separate the remainder off from the other terms. So an x cubed divided by a linear x should be giving us a quadratic coming out. So the last number is our remainder. So in this case, x minus 4 is not a factor of our original cubic function. We got a remainder out of it. So if I was going to write my result, I have the negative 37, and it's going to go over the x minus 4 because that was what I was dividing by. The fraction, whatever's on the bottom of the remainder, is always the thing that was on the bottom of the original problem. Like here, let me highlight. See, x minus 4 here means x minus 4 there under the remainder. Then the way I write this looks a little funny, but So I have my remainder. The term that comes before the remainder is the constant term. So we got that. Then the term before that is going to be the x term, which is what they're saying here. Give this one an x, and then the term before that will be x squared. So I'll sometimes like actually sneak those into the problem like that. But then there is our quotient and our remainder as a fraction. So if I figured out and got rid of the denominators here, cleared the fractions, it would be a true equation, an easier to evaluate true equation, I should say, or a test. All right, so you got to get the setup, drop down the first number, then multiply, add, multiply, add, multiply, add, multiply, add, however many times, box off your remainder, translate it back into an algebraic answer. So don't give me 2 minus 2 minus 8 minus 37 as an answer. That's a bunch of numbers strung together. It doesn't mean anything to me. You have to be able to take it back to this form. So now that ugly x to the fourth minus 81 we just did, we're going to do it with synthetic, much nicer. Not that what we did before was bad, it's just a lot of writing. We are still doing all the same work. We're just condensing it into a streamlined format. All right, so remember, we're going to take that bottom guy, x plus 3. Set it equal to 0. Get x by itself. So our c value is -3. That's what's going in the little box. Now our coefficients. I have 1x to the fourth. Then there are no x to the third, no x squared, no x's, and minus 81 for the constant term. Leave yourself a little space. Bring down the first number. And then we just do the thing. Multiply, add, multiply, add, multiply, add. All right. So -3 times 1 is -3. Add -3. -3 times -3 is now +9. And if you remember, we were getting alternating signs at the end of the last video. So this is a 9. Now this is -27. -27. -3 times -27 is a +81. So those add to 0. Box it off, and in this case, kind of throw it away because it's 0. So the result of dividing x to the fourth minus 81 by x plus 3 is, these are the coefficients. And remember, I start here. This is a constant. This is going to get the x. So this gets one more, and this gets one more. So I'm going to write that as x to the third minus 3x squared plus 9x's minus 27. No remainder. So that 4-term thing times x plus 3, what we were originally dividing by, would get us back to x to the fourth minus 81. So less writing work when you're doing synthetic. Like, it's certainly way more condensed, but you do have to be aware of, you have to account for all of those terms. So it can, when you're first doing this, help to, here's my first term. So this one's the third. This one's the second. This one's the linear. This one's the constant, which is actually technically x to the 0. And then down here, because I'm dividing by a linear, synthetic is always a linear factor. This result down here is always 1 power less than what we started with. Or you can do it backwards, constant, and count up. Either way works. For some reason, it just made sense to me to be like, this is the remainder, so this is the constant, so this is x squared cubed. I have a weird brain. All right. More of the same, because synthetic division's kind of fun. Like, see, I gave us a ridiculous one down there. But here, it's just out of order, which probably means there's a 0 we have to find. So let's start with the bottom, x plus 1. So if x plus 1 equals 0, x would equal -1. All right. So -1 in the box. Now our coefficients. So our highest power is this x to the 4th. So we're going to write a -2 here. Now this is a little unusual. Normally the first term is not negative, but it still works. So it's okay, just weird. Then x cubed is going to be a 5, x squared, yep, there's the 0, and then x, and then the constant. It's making a nice little pattern. All right, let's see what we get. Bring down the first one. Then multiply, add, multiply, add. So -1 times -2 is a +2. Add 7. -1 times 7, -7. Add -7. -1 times -7 to a +7, and we get a 9. And now we get a -9 and a whopping -14. All right. So x plus 1 is definitely not a factor of that mess. So we're going to write our result. So the remainder part is going to go over the original divisor, x plus 1. And then I'm going to sneak a plus in between here. And I say this because I've had a lot of students in the past, if this number on top was positive, they'll forget to write the plus in between. So I'm just going to kind of go with, just write it all the time, put that negative on top of the fraction so it kind of stays over there and isn't lost as an in-between symbol. Then I bring my 9, which is positive. This will produce -7x. This will be squared, and it's a +7. And this will be cubed with a -2. So there is our result written in the correct finished format. All right. So one more, just to be real crazy. We got x minus 2 on the bottom. So we got 2 in the box. We got a whole lot of numbers, but 5, 4, 3, 2, 1, 0. Just counting the powers. Everybody's accounted for, and it's presented in descending order. Sometimes the book does this for you. I wouldn't expect it to. Most of the time it does not. It's trying to trip you up, being jerks. So just be aware that's the trick, if you will, to the problem. So we can just copy these coefficients down in order: 2, 13, -3, a huge -58, then a -20, and a +24. Not that we needed the plus, but I'm going to leave it. Drop down the first term, copy it as is. Now, multiply, add, multiply, add. 2 times 2, 4. 13 plus 4 is 17. 2 17s, no shame in pulling out a calculator. I just do way too much mental math. Is 34. Add, we get 31. Oh, but that -58 is now going to be useful. So this is 62. But when I add that, I get a 4. This is now an 8. So a -12. And oh, would you look at that? We got a 0. All right. So it turns out that ugly mess on top is actually divisible by x minus 2. It can be written as x minus 2 times, let's fill them in. So this is an x. This would be an x squared. So this would be an x cubed. So this would be an x to the 4th. And that's why I like my big writing, because sometimes I can just shoehorn it in there and be like, look, answer. All right. So the third video is going to talk about the remainder of the section, but you may also be getting this from your college algebra professor, so I'm still going to record it. You don't necessarily have to watch it. The ALEKS homework from me, the objectives, is not going to contain work on this. It is literally just going to be a whole bunch of long division. But if you can use synthetic, by all means, feel free to. Just the notes, like if you view an example, it's going to show you long division. But feel free to pop by office hours if you want to practice these. I copied the problems out of the back of the book. I can always find more. And there's probably actually a fair number of videos on long division and synthetic division because it is one of the trickier things to remember how to do. Because by the time you get to this in high school, it's been a very long time since you've done long division. So a lot of students get lost. There's like Khan Academy and all sorts of videos. All right, I will see you in the next one if you so desire, or please come to office hours. Yay!